Hi everybody. So in this video, we're going to look at relative frequency and probability. We'll work through example 1 and example 2, and then we'll try some exam style questions. And if you want to work along with me, you can download a copy of this PDF from my website. I'll leave a link below. So relative frequency is the proportion of times that an event occurs compared to the total number of trials. To understand this, if we look at example 1, we're told that we've got a fair five-sided spinner and that Adrian spins the spinner 80 times. So this will be our total number of trials. We've been asked to work out the estimate for the number of times that the spinner lands on blue. So this will be our relative frequency. It's relative based on the 80 times that we've spun the spinner. So our proportion would be the probability of landing on a blue. And there's one blue out of the 5 different colours. And we're told it's a fair spinner. So the relative frequency will be the 1/5, the proportion of the sample, 80. And 1/5 of 80 is 16. So you'd expect we'll get 16 blues out of the 80 spins. Okay? So this is our relative frequency. And then to work out the relative frequency for not green, well, the probability of not green, so G dash, this dash means not. There are 4 colours which are not green, so this will be 4 out of the 5 in total. So the relative frequency will be this proportion of the total number of trials. So this will be 80 divided by 5, multiplied by the 4. 80 divided by 5 is 16. 16 times 4 will give us 64. So you'd expect 64 times we would not get a green. So in example 2, we're told that Stephen has a spinner, and when the spinner is spun once, the probability that it will land on a red is 2/5. Stephen spins the spinner 30 times. We've been asked to work out an estimate for the number of times the spinner lands on a red. So do you want to try this question yourself? Okay, so welcome back. So we want the probability of red. This is our proportion. And we're told that the probability it will land on a red is 2/5. So 2/5 of the number of trials, which is 30. Well, 1/5 of 30 is 6, and 6 times 2 would expect 12 reds out of the 30 trials. Okay, let's try another question. So in example 3, we're given that a factory produces microchips, and the probability of a microchip being faulty is 0.03. And one day, the factory produces 2,100 microchips. We've been asked to work out an estimate for the number of these microchips that are not faulty. So do you want to try this question yourself? So if we look at our proportion, this is the probability of it being faulty. We're told this is 0.03. But we've been asked to work out the numbers that are not faulty. Well, faulty and not faulty are mutually exclusive. Either one will happen or the other will happen. And they cannot both happen at the same time. So the probability of it being faulty plus the probability of it being not faulty must add up to 1. So to work out the not faulty, this will be 1 minus the probability of it being faulty, 0.03. So this will be 0.97. So this is our proportion. 97% of the 2,100 microchips would be not faulty. So we'll have 0.97 multiplied by the 2,100. And this will give us 2,037 not faulty. Okay? For example 4, We're told that a jar contains 100 coloured beads. 20 of these beads are blue. Gavin takes at random a bead from a jar. He records the colour of the bead and then returns the bead to the jar. He does this 60 times. Work out an estimate for the number of times Gavin records a blue bead. So again, do you want to try this question yourself? Okay, so we're looking at the blue beads and we're told that 20 of them are blue. So the probability of getting a blue will be the 20 out of the 100. And we can simplify this fraction to make 1/5. So 1/5 of all the 60 beads will be blue. So the blue beads will be 60 divided by 5, which is 12. So you'd expect there to be 12 blue beads, okay? Let's try one more question. So in this question, we're told that Georgia has a biased 5-sided spinner, and the table below gives the probabilities that it will land on a 1, 2, or 3. The probability that the spinner will land on a 4 is 3 times the probability that the spinner will land on a 5. Georgia spins the arrow on the spinner 150 times. We've been asked to work out an estimate for the number of times the spinner lands on a 5. So do you want to try this question yourself? So how did you get on? The first thing we need to do is to work out the probability of it landing on a 4 or a 5. And we're told the likelihood of it landing on a 4 is 3 times the probability of it landing on a 5. So if we let the probability of a 5 be x, then the probability of 4 will be 3 times this, which will be 3x. And we know that the total probability will equal 1. So we can work out x by adding up the 0.2, 0.12, 0.08, the 3x, add the x, which is 4x. And together, this will equal 1. We can add these decimals together, and we get 0.4 plus the 4x to make 1. We can move this 0.4 to the right-hand side. We'll subtract it from both. These will cancel. So 4x will equal 1, take away the 0.4. We can divide both sides by 4. These will cancel. So x will equal 0.15. And this is the probability of it landing on a 5. Probability of it landing on a 4 will be 0.45. So to work out the estimate for the number of times it lands on a 5, well, our proportion is 0.15 of the number of trials, which is 150. So we'll expect it to land on a 5 22.5 times. It's perfectly valid to leave it as a decimal because this is only an expectation, so you'd expect it to be around this number. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and the PDF that accompanies this video from my website, mrmathematics.com. I'll leave a link below.